Hello and welcome back to App for You. In this particular video, we'll be discussing a new problem basically from arrays, and it is one of the classical problems, the trapping rainwater, right? A standard problem, and here we can use some mathematical intuition behind solving this particular problem. You can visualize the problem and then you can come up with an idea to solve this particular problem. So what basically is the problem? Now here what has the problem says that we are basically provided with an array ARR. The size of the array is n, and the elements in the array basically represent some height of blocks, right? Height of blocks. The width of each block is by default 1. Assuming the width of each block is by default 1, we have to compute how much water can be trapped between the blocks during the rainy season. So to get more intuition behind the problem, you can just go through this particular problem. So here we can see there are blocks. So the very first block is of height 3, isn't it? 1 2 3, height 3. And what is the width? Width is 1. In the second one you will see no block is present, so height is 0. In the next one unit you will see that no block is present, so height is again 0. In the next one unit you will see there is a block of height 2 units, right? So height is 2. In the next one unit you will see there is no block, so basically height is 0. And in the last one unit you will find that there is a block of height 4. Now suppose you have this arrangement of blocks, and we know that if you want to pour something into it, if you are pouring some water or some liquid or anything, suppose if there is a rainy season, that water will definitely be accumulated, right, between the spaces. Now similarly you can see that here for this particular block it has already occupied the entire space. There is no space in the left, no space in the right, so basically no water will be trapped in this space. Considering this space, right, considering this particular region here, you can see the left space basically is supporting it. What is the height of the left tower? 3. Got the point? And you can see that in the right also you have plenty of space to store this water, right? So basically the right space you will see you can keep water here also, because it is being supported by a tower of height 4, because this tower of height 4 is standing straight here. And basically why this water level is not exceeding this, why this water level is restricted to this height, because you can see this is a height 4 and this here is the height 3, so minimum of 4 and 3 is 3. So basically it is a common logic that water will not rise this level, isn't it? The water level will not rise this particular, right? So water level will not raise this particular level. Why? Because although there is a tower of height 4, there is a tower of height 3 here, so we know that the maximum level of water contained will be basically depending upon the minimum of these two heights, right? So basically you can see we have restricted to height 3 level. Now how much water will be present in this space? So basically what I'm trying to say is height of this tower is 3,0,0,2,0,4. So if you keep on pouring water between the space, you will find that the water will restrict to this height only, right? And what is the height of this tower? The height of this tower is 3. What is the height of this tower? The height of this tower is 4. So do you think water will be restricted to this level, height 2? Definitely not. Why? Because we still have space left between these two towers, right? We still have space left between these two towers, and the height of this tower is 3 and the height of this tower is 4. So we basically, it means that we can accommodate more water in it. So basically the maximum water that can be accommodated here will be till this level, right? It will not be here. The water will never rise like this, right? Nor the water will come here, because it will lead to overflow. So water will be restricted to this height. So it basically means that it depends upon the minimum of the maximum heights. Getting the point? One idea that we developed right now, a very important, that we'll be using in the codes, is that the water level here depends upon, the water level that is allowed here will depend upon the maximum, the minimum of the maximum heights. So minimum of the maximum height means what is the maximum height in the right side? The maximum height in the right side is 4. What is the maximum height in the left side? The maximum height in the left side is 3. So the minimum of 3 and 4 is how much? So minimum of 3 comma 4 is basically 3. So basically you can see the maximum height in the left side is 3, the maximum height in the right side is 4, and the minimum of these two maximum height is 3. So basically water will be restricted to this height 3, right? Now how to calculate how much water will be present in this particular space? So if you look at this space, we know that the maximum height, that the maximum water level that can be present here will be 3, right? And what is the height of this block? The height of this block is again 3. So do you think any water can be accommodated? No. So 3 minus 3 is equal to 0. You cannot accommodate any water in this space. Come into this space. You know that maximum water that you can accommodate here is basically 3. We calculated right now, isn't it? Up to this level, up to this height. You found out the height. Now do you think now what is the height of the tower here? Obviously there is no tower here. So if there is no tower here, means height is 0. And we know that maximum water that can be accommodated here is 3. So 3 minus 0 is equal to nothing but 3, which means 3 level, 3 units you can store water here. Move to this section. In this particular section again, the height of the tower is 0. You know that maximum water level can be up to this level, and this is nothing but height equal to 3. So height equal to 3 minus the height of the tower, 0. 3 minus 0, nothing but 3. So 3 units of water can again be stored in this particular space. Now coming into this space, if you talk about this space, okay, if you talk about this space, what is the maximum height that water that can be stored here? That can be stored here is basically 3 again, right? Because we can see up to this level only. So 3. And what is the height of the tower in this space? 2. So these 2 units is already occupied by tower. How much water more can we store? This much water. So 3 minus 2. 3 minus 2 equal to 1. So 3 units here, 3 units here, 1 unit here. Considering this space again, how much water can be stored? Up to this height, 3. And what is the height of the tower here? 0. So 3 minus 0, which means 3 units of water can be stored here, right? 3 units. Now what is the height of the tower here? Basically 4, right? Height of the tower is 4. Getting the point? And we know that this is already exceeded the required height. Getting the point? It is leading to negative, isn't it? So no water will be stored here. No water will be stored here. Got the point? Now how to basically come up with this particular solution? The idea is very simple and straightforward. Now in order to solve this particular problem, we shall first of all keep track of the array. The array is basically nothing but 300. Let me just erase this and use this yellow ink. So the idea is first of all keep track of the array. The array is basically nothing but 300, 2, 0 and 4. This is the array that we have, right? Now this is the array with us. Now find out the left max. Left max in the sense, from left traverse the right and keep on track of the maximum value you are encountering. So if I am at this position, the maximum value encountered so far is 3. Now I came to this index. The maximum value encountered so far is 3. 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 So what does it indicate? It indicates that what is the maximum height of the tower in the left of this particular tower. So considering this particular tower, what is the maximum height in the left of this tower? What is the maximum height tower present in the left of this tower? What is the maximum height tower present in the left of this tower? And so on. Similarly, we will find R max, which will basically give me the information about the maximum height of the tower in the right of it. So basically I'll start from here now, right to left. So what will I do? I'll consider the initial array. So initial array, the tower height is 4. So maximum height tower observed so far is 4. Means maximum height of tower this tower is observing is 4. Now come to this particular value, 0. So obviously maximum height observed so far is 4 towards the right of it. What is the maximum height tower towards the right of it? Is 4 only. Come to this point. What is the maximum height tower observed so far towards the right of it? Basically 4 only. Come to this point. What is the maximum height of tower observed so far? 4 only. What is the maximum height tower observed so far towards the right of it? 4 only. What is the maximum height tower observed towards the right of it? 4 only. Got the point? So basically we have created 2 arrays. One array will give me the information about what is the maximum height tower in the left of a tower. Excuse me. So basically left max basically is giving me the information about if you are in a specific tower, what is the maximum height of the tower in the left of it. So this particular array will give you the information of that. 3. If you are standing in this position, you want to know what is the maximum height of the tower towards right of my side, right of this tower. Basically this array will give you the information of that. Okay. Now how can we use this to solve our problem? So let us now quickly zoom the screen and quickly start writing the code. So basically we know that we are going to use 2 arrays, right? So without delay we are going to use 2 arrays. Arrays will be lmax length n. Why we are using? To keep track of max height tower in the left of current tower. Similarly, int rmax, what will it do? Int rmax will basically keep track of the maximum height of tower in the right of current tower, right? So this will basically keep track of that thing in the right of maximum height of tower in the right of current tower. Done. What next? We will use two more variables. So let us suppose I. Done. And one more variable, suppose total equal to 0. Done. So total will basically keep track of the amount of water that can be stored. Now let us develop the intuition. So I have a tower of height 3. So let me write 1, 2 and 3. Done. Another tower of height 0. Done. Another tower again of height 0. Done. Another tower of height 2. Done. Another tower of height 0. So I am basically copying this array here, okay? Doing the diagram for this particular array. 0 done. And then you have a tower of height 4. Like this. So it is also done. So 1, 2, this is basically 3 and 4. Done. Now, how do you know, how will we know that how much water can be trapped? So for that particular reason, what should we do? We should, as I said, first of all keep track of what is the maximum height tower in the left and what is the maximum height tower in the right. So for that particular reason, I will run a loop from 0 till n I plus plus. And what will I do in the midway? Initially I will be declaring a variable integer again. So you can do all this thing in a single line. I am just writing separately, no problem. Integer max equal to array of 0. Initially I will suppose that the very first element is the maximum element, right? And again I will check that if array of that particular element I, if its value is basically greater than max, which means that we can update our max to that array, right? And then finally we will declare L max equal to array of L max equal to max, sorry. L max is equal to max, right? So let us not use max variable, let us use mx. Then excuse me. So I am declaring a variable max. So what will happen? What is happening now? After successful completion of this loop, what will happen? You will get this L max array. Why? Because you see right now the height of the array, height of pointer is here. So we know that mx is equal to 3 so far, because array of 0 is 3. Now you will compare whether this element is greater than 3, not. Then L max is equal to L max of I, basically L max of I. So L max of I is, L max is an array, L max of I will be mx, so basically 3. Pointer comes here, you have 0 here. Is it greater than 3? Definitely not. Then L max will be equal to max only. Then again 3. You are here again 0. This is also not greater than max. So again L max will be 3 only. 2 not greater than max. L max will be 3 only. 0 not greater than max. L max will be 3 only. 4. This is greater than max, right? 4 is greater than max. So L max should be equal to 4 here. I'm sorry, I've written 3 here. It will be equal to 4 here. So you have your L max array, which is 3, 3, 3, 3, 3, 4. Similarly, I will create my R max array. So I'll just copy this again. So in the next case, what I'll do, I'll create the R max array, which means from right to left I'll be moving. So in this particular case, my max value I'll be pointing to last variable, array n minus 1. Suppose the last variable is the maximum so far, and I'll basically traverse from n minus 1, and it will be greater than equal to 0, because reverse, isn't it? I'm traversing from right to left. I hope you can understand this. And this is basically nothing but I minus minus. And meanwhile I'll check that whether array of I is greater than max. If yes, then just update the value of mx and initialize R max of I to mx. Done. So what will happen? Now you see, you are starting from this point, moving towards here. So right now mx is equal to 4. Right now mx is equal to 4. So mx is equal to 4. So basically what will happen? R max of I will be equal to mx. So 4 will be initialized. Come here. You have variable 0, value 0. So 0 is obviously not greater than 4, which means mx still remains 4 only. So it will be 4 only. R max of I will be declared 4 only. Come here. 2. 2 is not greater than 4, which means max will be 4 only. Come here. 0. Not greater than 4. Max will be 4 only. Come here. 0. Not greater than 4. Max will not be updated. So max will be 4 only. Come here. 3. Not greater than 4. So max will be 4 only. You can see this is just the working of this code. You can understand. So basically, I have successfully found out my left array also. So basically this is my array 3, 0, 0, 2, 0, 4. If you talk about L max, then basically L max will be here 3, 3, 3, 3, 3 and 4. Talking about R max R max basically we found out to be 4, 4, 4, 4, 4 and 4. So we are done with these two values, right? We are done with these two arrays. Now how to use these two arrays? Now we very nicely know that, now we know it properly, that water trapped will be depending upon the minimum, right? Water trapped here is depending on what? See, water trap is depending upon the minimum height in the left and the maximum height in the left and the maximum height in the right, right? And we will take the minimum of it. So basically the trick is, again we'll run a loop from 0 I less than n I plus plus, and similarly I'll check that if basically total plus is equal to basically how much water will be acquired, that will be equal to minimum of L max of I, right? L max of I, not minimum, actually it will be maximum, yeah, minimum of L max of I comma R max of I, right, minus array of I. This is the amount of water that will be contained. Now how will we calculate this? You see the working. So initially total is 0, so total equal to 0. What will happen? Right now I am here. So what is the maximum height tower in the left? 3, right? What is the what is the maximum tower in the right? 4, right? So what is the minimum of these two? The minimum of these two is 3, which means that the water level height that can be used here is 3. You can store only up to this height, 3. So this value will be here 3. 3 minus array of I. Array of I is how much? Array of I is here 3 again. So 3 minus 3 is equal to 0. So again 0 plus 0. Done. Similarly, what will happen in the next? In the next case, we have basically the I pointer points here. So the minimum of this and this is how much? So this says that in the left of this tower you have a minimum maximum height of 3, and in the right of this tower you have a maximum height of 4. And you know that the height will be depending upon the minimum of the maximum height in the left and the maximum height in the right. So minimum of 3 and 4, which is nothing but 3. So 3 minus again the height of this tower, 0. So 3 minus 0 plus. Similarly for this particular region, the minimum of 3 and 4 is 3. The height of the tower is 0 plus. In this particular case, the minimum is 3 comma 4 is 3 minus height of this tower is 2 plus. In this particular region, the minimum is basically 3, height of the tower is 0 plus. Here the minimum is basically 4, and 4 minus 4 is nothing but 0. So what is the total amount of water that will be stored? So you will be having 0 plus 0 plus 3 plus 3 plus 1 plus 3. That is nothing but 10, right? So that is the answer to this particular question, and let us see how this particular problem works. So I'll not make the video lengthy. I'm sorry, we have to return the total. So return total. Yeah, we have to return the total, and the variable mx should also be declared. So yeah, it is declared here, no problem. So mx previously declared here. What is the problem? The problem is, okay, why I'm declaring it again. That is the problem. So yeah. Yes, we got the answer. The height will be 10 and we verified it. So yeah, that's all from this particular video. I hope this video was helpful and you got the intuition behind this. Okay, some little mistake. Okay, what is the problem? Okay, so basically we are not dealing with, you know, the large values, right? So I think we should deal with this particular problem by replacing it with long int, right? Because you see, the problem is we are having larger values here, right? Let me just show you. So here basically the domain is the domain of the variable n is quite large. So and AI is also large, right? 10 power 8. So it might lead to overflows. So for that, basically it is advisable to use, let me see. All right, okay, fine. So we will be basically using long int, right? Let's see if this solves the issue. Okay, greater than minus 0. I don't know why I've written minus 0 here. Greater than equal to 0, right? So yes, I think now it should work fine. So yeah, that's it. Okay. So you can use long int, and even if you don't write long int, it should work. But I think it is a good practice to basically prefer writing this, because sometimes we may not go through the domain of the value, and then we may end up giving wrong answers. So yeah, that's all from this particular video. I hope this video was helpful and intuitive. In case of any doubt, please feel free to put it out in the comment section, and just like, share and subscribe. Thank you.